Hello dear students, this is your Engineering Mathematics 3 lecture. Today's topic is solution of ordinary differential equation by using numerical methods. This topic is from 6th unit, the method to find the solution of ordinary differential equation. There are different methods. The first one is Euler's method. Euler's method is the numerical method to find the solution of the ordinary differential equation. See the Euler's method. Suppose your differential equation is of the type dy by dx is equal to f of xy, with x is equal to x0, y is equal to y0. Means x is equal to x0 and y is equal to y0. These are the initial values of x and y. X naught and y naught are the initial values of x and y respectively. Then the formula to find the solution of ordinary differential equation by using Euler's method is, this is the formula: yn plus 1 is equal to yn plus h into f of xn yn. What is the h here? H is the difference between two consecutive values of x. That is h. Here we have written h is xn plus 1 minus xn. Means the difference between two successive consecutive values of x. That is your h. This is the generalized formula. You can find y1, y2, y3. If we put n is equal to 0, then you will get y1. y1 is equal to, now n is 0, so y1 is equal to y0, means y naught, plus h into f of x naught, y naught, because n is 0. F of x naught, y naught. X naught, y naught, these are the initial values of x and y respectively. So putting the values of x naught, y naught here in this formula, you will get y1. To find y2, put n is equal to 1. N is 1, so 1 plus 1, 2. So you will get y2. Y2 is equal to, n is 1, so y2 is equal to y1 plus h into f of x1, y1. Similarly, you can find y2, y3, y4, yn plus 1. Okay. So this is the generalized formula of Euler's method. Now see the example. Using Euler's method, solve the differential equation. Solve the following differential equation: dy by dx plus 2y is equal to 0. Y of 0 is 1. Dy by dx minus 1 is equal to y square. Y of 0 is equal to 0. In each case, you take h is equal to 0.1 and obtain y of 0.1, y of 0.2, y of 0.3. This is the example. We are going to solve two differential equations here. First, and this is second one. Solve one by one. Initial values of x and y are also given. Now in each case, we have to take h is equal to 0.1 and obtain y of 0.1, y of 0.2, y of 0.3. In each case, take h is equal to 0.1 and obtain y of 0.1, y of 0.2, and y of 0.3. Okay. Now here, first differential equation is there. Dy by dx plus 2y is equal to 0. So dy by dx is equal to minus 2y. Because we want a differential equation in the form of dy by dx is equal to f of xy. We want the differential equation in this form. In LHS, the term will be only dy by dx, and remaining terms you transfer in RHS side. That will be your function f of xy. So here in this example, the equation is dy by dx plus 2y is equal to 0. So you transfer this plus 2y in RHS, so that the equation will be dy by dx is equal to minus 2y, which is equal to f of xy. Okay. Now here we are going to take h is equal to 0.1. Now the initial condition is here y of 0 is equal to 1. Y of 0 is equal to 1 means this 0 is the value of x. In bracket, the value is of x. X is equal to 0. and y is equal to 1. The RHS side value, this 1 is the value of y, and this bracket term value is of x. So initially x is 0 and y is 1. So initially we give the notation for x and y, x naught, y naught. So x naught is 0 and y naught is 1. So these are the initial values here. So right here, h is equal to 0.1, x naught is 0, y naught is 1. So by Euler's formula is here, yn plus 1 is equal to yn plus h into f of x and yn. This is the generalized formula. So here we are going to find y1. So for y1, y naught is 1 and x naught is 0. So to find y at h is equal to 0.1. So y1 is equal to y naught plus h into f of x naught y naught. So here y naught is here 1 and h is 0.1. So y naught is 1 plus h is 0.1, f of x naught y1, x naught y naught. So your f of xy is here minus 2y. So replace x by x naught, y by y naught. So f of x naught y naught is minus 2y naught. Minus 2y naught. What is y naught? Here y naught is 1. So put y naught is equal to 1. So it is 1 plus 0.1 in bracket f of x naught y naught. F of xy is here minus 2y. And we are finding here f of x naught y naught. So replace y by y naught. So minus 2y naught. Minus 2y naught. Y naught is here. Value of y naught is 1. So put y naught is equal to 1. You simplify the term. And then your answer is here y of 0.1 is 0.8. So here we are going to find, in each case take h is 0.1 and obtain y of 0.1. We are finding y of 0.1. So to find y at h is equal to, what to do? We are going to find y at h, x is equal to 0.1. So how to find it? By using Euler's method. You find x1. How to find x1? X naught plus h. What is x naught? X naught is 0. What is h? H is 0.1. So x naught plus h is x1. So 0 plus 0.1 is 0.1. So your x1 is 0.1. So for 0.1, when x is 0.1, you find the value of y using Euler's formula. So this is your formula. Y1 is equal to y naught plus h into f of x naught y naught. And here you put all the values. Then y of 0.1 is 0.8. Okay. Now again we have to find out, obtain y of 0.2. Obtain y of 0.2 means find the value of y when x is 0.2. So how to find? See here. To find y at x is equal to 0.2. So y of 0.2 is equal to y1 plus h into f of xn, f of x1 y1. We are finding here y2. So y naught is, we are finding y2. So y2 is equal to y1. Y1 is 0.8 plus h is 0.1 into f of x1 y1. F of x1 y1. Here f of xy is here. What is the function? F of xy is minus 2y. So what will you f of x1 y1? You just replace this y by y1. So f of x1 y1 is minus 2y1. Minus 2y1. So minus 2 into y1. Y1 is 0.8. Here it is 0.8. So minus 2 into 0.8. So simplify it. And so y of 0.2 is 0.64. Okay. So this is the value of y at x is equal to 0.2. Now find y of 0.3. You can find y of 0.3. To find y at x is equal to 0.3. This is your y3. Y3 is equal to y2 plus h into f of x to y2. Y2 is 0.64. So put it here 0.64 plus h 0.1 into f of x to y2. What is f of xy? It is minus 2y. So minus 2 into y. Now your y is here y2. So y2 is 0.64. Put here 0.64. Simplify it. You will get y of 0.3. It is 0.512. Okay. Now the second differential equation is here. dy by dx minus 1 is equal to y square when y of 0 is 0. Now you simplify in standard form this dy by dx minus 1 is equal to y square. You shift this minus 1 in RHS, so that you will get the equation dy by dx is equal to y square plus 1 is equal to f of xy. Okay, dy by dx is equal to the remaining term must be in RHS, that is the standard form, and then the RHS term is nothing but your function f of xy. Here initial condition is y of 0 is equal to 0, means when x is 0, y is also 0. Means x naught is 0 and y naught is also 0. H is 0.1. Therefore, by Euler's formula, general formula is yn plus 1 is equal to yn plus h into f of x and yn. Now we are going to find x where x is equal to 0.1. Now see, what is x naught? X naught is 0 plus h. X naught plus h is 0.1. We are going to find the value of y when h is, we are going to find the value of y when x is 0.1. X naught plus h is our next value of x. So here the first approximation, y is equal to y naught plus h into f of x naught y naught. This is from the generalized formula of Euler's method, Euler's formula. So y1 is equal to, what is y naught is 0, h is 0.1, and what is f of x naught y naught? So what is your f of xy? Y square plus 1. So your f of x naught y naught will be y naught square plus 1. It is y naught square plus 1. So what is y naught is 0. So put here the value of y naught plus 1. Simplify it. So y of 0.1 is 0.1. Same. And x is 0.1, y is also 0.1. To find y at x is equal to 0.1. Sorry. To find y at x is equal to 0.2. Here it is small correction. To find y at x is equal to 0.2. How to find x1 plus h? We are going to find x2. X1 we already we have the value of x1. For x1 the value of y1 is 0.1. X1 is your 0.1. Now what is x2? X2 means x1 plus h. X1 is 0.1 plus h. H is again 0.1. So 0.1 plus 0.1, x2 is 0.2. Find y at x is equal to 0.2. So this is a second step. So y of 0.2 is equal to y1 plus h into f of x1 y1. Y1 is your 0.1 plus h is 0.1 in bracket f of x1 y1. F of x1 y1 square plus 1. What is y1? Y1 is 0.1. So it's square plus 1. Simplify it, you will get y of 0.2 is equal to 0.201. And so on. And the next is also y of 0.3. Find y of 0.3. Y of 0.3 means y2 plus h into f of x2 y2. Now you know that your x2 is 0.2. Now x3, to find x3, x2 plus h. X2 is your 0.2 plus h. H is 0.1. 0.2 plus 0.1 is 0.3. So this is your x3. 0.3 is your x3. So for this x3 you find y3. So formula of Euler's method, y3 is equal to y2 plus h into f of x2 y2. What is y2? Y2 is 0.201 plus h is 0.1 into f of x2 y2. x2 y2, y2 square plus 1. What is y2? Y2 is 0.201 whole square plus 1. Simplify it, and so y of 0.3 is 0.3. Okay, and so this is the answer here. This is the example of Euler's method. Similarly, you can find solve the next example also by Euler's method. Solve by Euler's method. The equation dy by dx is equal to x plus y, where initial condition is y of 0 is equal to 0. Choose h is equal to 0.2 and compute y of 0.4 and y of 0.6. See here in this example, the initial values are initial values of x and y are x is 0 and y is also 0. Means x naught is 0 and y naught is also 0. This is your differential equation. h is 0.2, and what we have to find? Y of 0.2. Means when x is 0.4, you find the value of y. So how to find it? We have to find out y of 0.4 in two steps. In two steps. Here h is 0.2, x naught is 0, and y naught is 0. So how to find x1? X1 means x naught plus h. X naught is 0 and h is 0.2. So 0 plus 0.2 is 0.2. So by using Euler's formula, you find first y1 when x1 is 0.2. Actually our aim is find the value of y when x is 0.4. But here we have to find out the value of y when x is 0.4 in two steps. First, you find the value of y when x is 0.2. Why? Because our h is 0.2 and x naught is 0. So x naught plus h is x1 and it is 0.2. So we have to find out for 0.2 first, the value of y when x is 0.2. And then in next step, you add x1 plus h. X1 is in first step 0.2 plus h. 0.2 plus 0.2, 0.4. And then you'll get the value of y at x is equal to 0.4. So in next step, in second step, you will get your answer. You have to go by step by step because of the value of h, because the value of h is not here 0.4. So that will get your answer in one step. Here in you will get your answer in two steps because your h is 0.2 and your aim is you find the value of y when x is 0.4. To reach up to 0.4, you have to do two steps because your x naught is here 0. 0 plus 0.2 is 0.2. So you find the value of y when x is 0.2 first by using Euler's formula. Your formula is y1 is equal to y naught plus h into f of x naught y naught. Your x naught y naught both are zeros. Y naught 0, put y naught 0, h is 0.2. F of x naught y naught. What is your f of x y? X plus y. So f of x naught y naught is x naught plus y naught. Both are zeros. So 0 plus 0, 0. So your answer y of 0.2 is 0. Okay. So when x is 0.2, your y is also 0. Now when x is 0.4, what is y? Here find y at x is equal to 0.4 means you are going to find y2. To find y2, it is equal to y1 plus h into f of x1 y1. What is your y1? Y1 is 0. Y1 means the value of y at x is equal to 0.2. It is 0. So it is 0 plus h is 0.2. F of x1 y1. This is f of x1 y1. What is your f of xy? It is x plus y. So your f of x1 y1 will be x1 plus y1. So what is x1? X1 is 0.2. What is y1? The value of y is 0 when x is 0.2. So 0.2 plus 0. Simplify it, you will get y of 0.4 to 0.04. And then in next step, third step, you will get y of 0.6 because this is your x2. X2 plus h, 0.4 plus 0.2, it is 0.6. So this is your x3, 0.6, and you will get y3. The formula to find y3 is y2 plus h into f of x y2. And then you put here all the values, then you will get your correct answer. When x is 0.6, the value of y is 0.12. So these are the examples on Euler's method. Now discuss here Euler's method with few examples. So this session is over here. Thank you.